So today's lesson will be on ionic solids. So we've worked out the shapes, the polarities. Now it's time to actually look at the properties of all these compounds and molecules. So the first one we're focusing on is ionic solids. So solids are classified according to their chemical and physical properties. It'll depend on the particle type and also the bonding between and within the particles. So within is known as intramolecular and between is known as intermolecular. So our learning outcome for today, hopefully by the end of the lesson, you will be able to explain the properties of ionic solids in terms of their structure and their bonding. So ionic solids, the prime example is table salt sodium chloride. So the general properties of ionic solids are that they have a high melting point, they conduct electricity when molten, and they're hard, but they're brittle. Okay, so if you have a hammer, you smash it, it's going to break. So ionic solids are made of ions, okay, it's in the name, which sit in a three-dimensional network of positive and negative ions. And as we've previously discussed in previous lessons, the ions are held together by electrostatic interactions or ionic bonds between the positive and negative ions. And here's a great example here of, say, sodium chloride, where the green is the sodium ion and the chloride is the purple ion. So even though the formula is NaCl, it's actually consisting of thousands of sodium ions and thousands of chloride ions in this three-dimensional network or lattice. It's going to take a lot of energy to break those bonds. And this is the reason for the melting points of ionic solids. So ionic solids have a high melting and boiling point. And the reason why this is because the ions are held together by very strong electrostatic forces, the ionic bonds. It takes a lot of energy to break those bonds. And as you can see from the diagram, you input the energy, you break it. What you're doing is you're actually breaking the electrostatic attraction of the ions between each other, between the positive and negative ions. And because we know opposites attract electrostatically, it means it requires reinforcing that a lot of energy to break those bonds. In terms of conductivity of ionic solids do not, I repeat, do not conduct when they're solid, because as you can see from the diagram, the ions are fixed in fixed positions and cannot move. In order for a charge to move through a solid, the charge carrier, in this case the ions, has to move. And that only happens when the ionic solid is either melted or is put in water, which we call an aqueous solution. Okay? Because when they're molten or aqueous, the ions are now free to move and so can conduct electricity. So in terms of the hardness of ionic solids, the hardness is due to the strong electrostatic attractions between the negative and positive ions. And there's just a picture of that there, how hard they are. However, although they're hard, they're very brittle. And the reason why ionic solids are very brittle is because, as we've seen in the last illustration, the ions are fixed in fixed positions, and if a force is applied, the ions will then shake out of position, and these charges will line up against the repulsive forces of the like charge, as you can see from the diagram. Give it a sharp blow, you end up having positive and positive charges next to each other and negative charges, and they're going to repel because like charges repel, and the crystal breaks. And there's just a diagram which illustrates that point. As you apply a force, what happens is that you're pushing the ions out of position. The positive charges then are next to each other and negative charges are next to each other, and they're going to repel and break apart. Okay, so that's enough for today's lesson on ionic solids. The next lesson we'll move on to covalent solids and liquids.